Hello, everyone. Today I am going to do section 5.6. I'll do two problems on each video if you need to watch these. Today should be on a Wednesday, I hope, to help with these, and go ahead and do that. If not, probably good. We probably won't go over these in class, but we'll go over some other ones. So we're going to start with number one. We'll just do two things. We got 1 and 3 first. Number one says, the radius r and the area a of a circle are related by the equation a equals pi r squared. A lot of times we're going to have to come up with our own formula, but here it's given to us. Write an equation that relates dA dt to dr dt. So this is just kind of warm up. You would have these rates normally. So remember that both the area and the radius are some function of time. So we just treat it like a implicit differentiation problem. So we take the area of A, it would be 1, but then times dA dt, which is the derivative of A, because remember A is some function of time. And then we take this derivative, it's 2 pi r, but then we need the dr dt. So there's a relationship, straight and simple, that relates dA dt with dr dt. So that's just kind of reminding you how to do that implicit differentiation. Number 3 is the radius r, height h, and volume v of right circular center related by the equation volume equals pi r squared h. How is dv dt related to dh dt if r is constant? So if r is constant, that means when I take the derivative, that just hangs there, just like the pi is going to hang there, or in the first problem, the 2 pi hung there. So we're going to go dv dt. And then this pi r squared is just a constant, so it's just going to hang there. And then the derivative of h would be dh dt. Part B says, how is dv dt related to dr dt if h is constant? So same basic idea. And then we got dv dt. And now we're going to go 2 pi r dr dt. But then that h is just going to hang there because it's just some number. It's a constant. So when you take the derivative of that constant, or sorry, you don't take the derivative of that constant, it just floats around, right? And then part C says, how is dv dt related to dr dt and dh if neither is constant? So now we're going to have to do a product rule. This would be a lot harder if we had some real problems to do. So we're going to go dv dt equals, now pi is just going to hang around. All right, maybe I'll just take it out, the whole thing. And then we have this r squared h. So that's just a product rule, right? So we got r squared h as a product rule. So we're going to go 2r, that's through that first term, times its rate, dr dt, because remember r is some function of time, times the second term, which is h, plus the derivative of that second term, which is dh dt, times the first term, which is r squared, just a little product rule. We would have to have some sort of relationship if we were doing this problem, or some of the numbers, one or the other. So that's it for 1 and 3. I'll come back for the next 2 in just a bit.